So moving on, we've talked about, the three main or the six main graphs you would see in a projectile motion problem. And remember that it's all based off the one idea that the only thing we're dealing with is acceleration due to gravity, which is negative 9.81 meters per second squared if we assume down is negative. So everything we do is based off that. Let's go down to this page. So now we're going to look at, and there's a lab that goes with this that, I'm not going to cover here. Hopefully we have time in class to do it, but I'm just skipping ahead. And I'm just going to ask you, can these be possible graphs we see in projectile motion? So the first, is this possible? This v of x graph. So remember, I'm going to walk us through v of x. So velocity in the x direction. And they ask us versus time, and is this possible? And I would say, yeah, this is possible because an object that's going through projectile motion is only experiencing a negative y acceleration. There's no x acceleration. This is an object not accelerating. Its speed is the same. Let's say that speed is, let's just round it to 25. So let's say 25 meters per second. They ask us how far this object's gone. Can I figure that out? Yeah, all I have to do is take the area, right? So this area here is going to be 25 times 4. And I'll get 100 meters. So nothing new. We can still use our graph method. Let's look at this object. Is this possible? My VYT graph. Now, this object is starting off with 0 meters per second in the vertical direction. So remember, y is our vertical. And it's going to do this. It's going to, in 4 seconds, it's going to drop by, it looks like about 40. Now, I know I said g is 9.81, but you can approximate that to 10, negative 10. And my suggestion is, I'd rather us work with negative 10 than negative 9.81. It's actually, for a human, you would not really be able to notice the difference in real time, most likely. Unless you're very sensitive to seeing stuff like that. So for now, so that we don't have to bust out our calculators, let's just say negative 10 is our g. And that's what the slope looks like. Every second I increase my velocity by negative 10 meters per second. Let's determine how far this guy travels vertically. So I would take the area. Now this area would be 1/2 times negative 40 times 4, and I get negative 160 times 1/2, negative 80 meters. So they want us, let's say graphs 1 and 2 both describe the same projectile. They want us to draw what this object's doing. And so I'm just going to make it, really what it is I'm just going to make a drawing. So don't worry about position, time, whatever. So this object, he's going to start off going horizontal, and maybe that's too horizontal, but he's going to start off with no vertical velocity, but it's going to increase to negative 40 meters per second. So it's very flat, and then it goes down. Now notice I'm not drawing a parabola that's going up, right? Because I never had a positive velocity. So I have to start where my tangent looks flat, and then it gets more steep in the negative direction. All right, so I'll tell you now, so how far does he go? Well, I solved it before, 100 meters. How high are they going? Well, I can say I start at 80 meters and I drop down to 0 meters. So I can think of this as I threw something off a cliff, I just threw it straight ahead, and if I'm 80 meters above, then the rock or whatever object fell 80 meters and it went over 100 meters. All right. So hopefully this diagram isn't too confusing. I'm going to move on to the next one. And I want you to practice what they're asking for here. So you try to see if you can do the exact same thing I did and figure out some information about this object. So I'll pause the video, you guys work on it, and then we'll get back. So hopefully you pause the video, you practice it on your own. Let's talk about this. So we have this object here, and they ask us at what time does the projectile reach its maximum height? With these problems, a y versus t graph yes, it's hard to actually get a lot of different information about it, but I always find that if you draw what happens, it helps so much with these problems. So I have an object that's starting off going up, but then it's going to slow down because that's how things in projectile motion work. And then it's going to go back down, and then it's actually going to end lower than it started. And how do I know that? I'll show you in a second, but you can see that it travels more time in the negative values than the positive values, so I know that's going to happen. Now they ask us at what time it happens. Now I know on my y versus t graph, this is the highest it will be, but can I link it up here? So I should know that only this time period here I'm moving up. Anything after, I'm moving down. So at this time, which is 4 seconds, that's when I reach my maximum height. And they ask us for the value of that maximum height. It's going to be 1/2 times 40 times 4. So we're going to get positive 80 meters. So 80 meters is my max height. And you know what? I can even label it here just to help things out. So I'm at 80 meters. Then they ask, was this projectile fired from a horizontal position? How do you know? So that's like a term, fired from a horizontal position. What they mean is, did they throw the rock or whatever, fire this projectile this way? And let's go back to our drawing that I made. And this is how they threw it. So that arrow does not line up with this arrow. So the answer would be no. Another way I know is that my initial y velocity, my VOY, is not equal to 0 meters per second. If it was equal to 0 meters per second, then I could say, okay, it was fired from a horizontal position, but in this case, it's not. It's greater than 0. It's positive 40 meters per second precisely. So now they ask us how far above or below its initial position does it land. So to find that out, I just need to figure out this 1/2. It looks like we get to negative 60 meters per second, and that takes it 6 seconds. Remember, we're assuming that this slope is negative 10, not negative 9.81. If it was negative 9.81, it'd be a little less. It'd be maybe about like negative 58 point, I don't know, 6 or something. All right, negative 60 times 6 is negative 360 times 1/2. We're going to get negative 180 meters. Now, we have to combine the first half with the second half. And so I'm going to land at negative 100 meters, or you can call that at 100 meters below its initial position. That might seem kind of far, but that's just the nature of how acceleration works. Basically, these first 4 seconds cancel out with these 4 seconds. The last 2 seconds are actually a lot of area that's being covered. So at that point, you're traveling at 50 meters per second and 60 meters per second. And so you're going to travel pretty far. All right, hopefully y'all don't have any questions on this page. We're going to move on. Now this one. So now I'm going to ask y'all, are these possible? Are they not possible? Let's talk about it. So basically, can this happen in projectile motion? And I'll remind y'all, basically the only thing we have to assume in projectile motion is a of x is 0, a of y is negative 10 or, negative 9.81 meters per second squared. So somewhere in this range. All right. Does v of x show that? This v of x. So this is velocity in the x direction. I'm going to put some numbers here. This is 0 meters per second. Let's just say this is 5 meters per second. I'm just using a random number. And I would say, no, your a of x is 0. So this should just be a flat line the whole way through for it to be possible. So no, not possible. There's no acceleration in the x direction. Let's go to the y-t graph. Our y-t graph, this is vertical position change. Now, let's say this is 0 meters, and let's say this is 10 meters. Let's say this is 1 meter, and this is like 2 meters, and then this is like, sorry, 1 second, and this is like 2 seconds, and this is like 4 meters. And what I'll notice is that every second it looks like I'm traveling at the same constant speed. So this one's no. It's not possible. Why? You need to be accelerating in the y direction. So we need to see some kind of downward parabola. And it's a very specific acceleration. It needs to be a downward parabola. All right, this last one. Is this possible? So here's an object. Let's say this is 0 meters. It looks like I'm traveling to like a negative direction. I'll call that negative 10 meters. So is this possible? So I'm looking at this. Is it accelerating? So not accelerating. And because it's a horizontal direction, my a of x is 0, which is what I want. So is this graph possible? But it's going the negative direction. So it is possible. It's traveling to the left. So all this is just someone threw an object to the left. And because he's throwing it to the left, it has a negative velocity, but a negative constant velocity. And that's all that matters for this situation. So you can throw objects right or left. As long as they're moving at constant velocity, then I know it's okay in that direction. All right, hopefully y'all feel good about that. It's been about 11 minutes. So I'm going to pause the video here and we'll move on to some calculations.